afternoon to everyone, and today we'll discuss about the new concept, the nature of electromagnetic radiation. Okay, before going to this topic, light also has a dual character, but the light has a particle nature as well as a wave nature. The particle nature of light can be explained by Newton scientists, and then the wave nature of light can be explained by Huygens scientists. Okay, so Newton can explain the particle nature. Newton explained particle nature of light. Huygens explained wave nature of light. Wave nature of light. So finally the light is transmitted in the form of wave. Okay, and based on these concepts, the James Maxwell light and other form of energies, light as well as a other form of energies, they are propagated in the space. They are propagated in the space through a waveform. Through a space in waveform. Okay. The light and other form of energies can radiate. The radiant energies are transmitted in the form of a wave. Here the wave is consists of the electric field as well as a magnetic field. That light can propagate it in the form of wave. That wave is consist of the both electric field and then magnetic field. That's why that wave is called as electromagnetic wave or electromagnetic radiation. Electromagnetic wave or electromagnetic radiation. Okay. Electron also present under the acceleration. Electron also present under the acceleration. Electron is nothing but negatively charged particle. Any charged particle present under the acceleration. Acceleration is nothing but rate of change of velocity. Whenever the negatively charged particle or any charged particle present under the acceleration, perpendicular to the oscillating charged particle, electric field is created. Again, the perpendicular direction of electric field, magnetic field also produced. All these things are transmitted in the form of one wave. Then it is also called as a electromagnetic radiation or electromagnetic wave. Okay. James Maxwell can explain the nature of the electromagnetic radiation. Then what are the characteristics of electromagnetic radiation? Characteristics of electromagnetic radiation. Characteristics. In that, the first one is the oscillating electric field and magnetic field both are perpendicular to each other. The oscillating electric field and magnetic field perpendicular to each other, and they are again perpendicular to the oscillating direction of the wave. Oscillating direction of the wave. Electric field and magnetic field perpendicular to each other. Then what is the direction of the wave? That also perpendicular to the both electric field and then magnetic field. That is the first characteristics. Oscillating electric and magnetic field perpendicular to each other. Oscillating electric field and magnetic field both are perpendicular to each other. and they are also perpendicular to the oscillating direction of the propagation of the wave. Okay. Next, the wave propagated with the speed of the electromagnetic radiation the speed of electromagnetic wave is 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second. The speed of electromagnetic wave is 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second. This value is equal to velocity of light. That means all electromagnetic radiations are travel with equal to the velocity of light. 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second. Next, third point, electromagnetic radiation is comprised of 7 different radiations. Electromagnetic radiation is consists of the 7 different radiations. It consists of 7 different radiations, and one is a gamma rays, and second thing is a X-rays, ultraviolet, visible, IR region, microwaves, and finally radio waves. So these are the 7 different radiations are available in the electromagnetic radiation: gamma rays, X-rays, ultraviolet, visible, IR, infrared, microwaves, radio waves. These are the majorly 3 characteristic properties of the nature of electromagnetic radiation. Next, what is the nature of what is the meaning of wave motion? What is the meaning of wave motion? Wave motion is nothing but, generally whenever taking any stone, the stone is thrown into the pond or lake, the disturbance is created, then the water is transmitted from ups and downs, like that the water can be transmitted. Okay, now before throw to the stone, the water is present in the rest position. Whenever any disturbance is created in the pond or lake, okay, now with the help of stones or anything, then automatically from the centered base where the stone is thrown, from that point, okay, now the water is transmitted. The water is moving from ups and downs. Then the property is called as a wave. Wave is nothing but the disturbance which is present in the medium, either water or air. The disturbance which is present in the medium. Okay. Here also ups, downs, like that will be. Okay. Here maximum upward displacement is present, and then the maximum downward displacement also present. Then what about the names of these parts? What is the maximum upward displacement, and then what is the maximum downward displacement? Here we are giving the some of the names. It is a crust and trough. Crust and trough. What is mean by crusts? What is mean by crust? The maximum upward displacement crust is nothing but the maximum upward displacement is called as a crust. Here the maximum upward displacement from this point or from this plane we will take it that this is the maximum upward displacement. Then this point is called as a crust. Crust, crust and crust. Then what about this trough? The maximum downward displacement. The maximum downward displacement. The maximum downward displacement is called as a trough. The maximum upward displacement is called as a crust. So the wave is transmitted, or the wave is consist of the crust and trough. Crust and trough. Along the characteristic properties, the electromagnetic radiation is also associated with some properties. Okay, now up to now whatever we discussed, the 3 points, they are the general characteristic properties of electromagnetic radiation. But along that, the electromagnetic radiation is associated with few properties. In that, the first one is a wavelength. Wavelength is nothing but the distance between the two successive crusts and troughs. The distance between the two successive crusts or two successive troughs. It is called as a wavelength. And I will take the one of the wave. Now the distance between the two successive crusts or the distance between the two successive troughs, it is only called as a wavelength. The wavelength is denoted by lambda. It is denoted by lambda. Lambda. Then what about the units of wavelengths? What about the units of wavelength? The units of wavelengths are nanometers, angstroms, picometers, either centimeters or meters. But majorly the nanometers, angstroms and picometers are using. To express the wavelength units, these are the majorly three things: nanometers, angstroms, picometers. Wavelength units: nanometer, angstrom, picometer. These are the units of the wavelengths. Then again, what are the values of 1 nanometer, 1 angstrom and then 1 picometer? One nanometer is equal to 1 nanometer is equal to 10 power minus 7 centimeter, 10 power minus 9 meters. Or 1 angstrom is equal to 10 power minus 8 centimeters, or it is equal to 10 power minus 10 meters. And 1 picometer is equal to 10 power minus 10 centimeters, or that is equal to 10 power minus 12 meters. They are the units of the wavelength and then the respective values. Nanometers, angstroms, picometers. Next to frequency. How to define the frequency? How to define the frequency? The number of waves passes through a given point in given time. The number of waves passes through a given point in a given time. Or the number of waves traveled in the particular distance by how many wavelengths. Or how many wavelengths. Okay. So that is called as a frequency. Or one more definition also we will take it, the reciprocal of the time period. The reciprocal of time period is also called as a frequency. There is a 3 definitions we are explaining to frequency. The first one is the reciprocal of time period. Or the number of waves pass through a given point in given time. The number of waves passes through a given points in a given time. That is also called as a frequency. And it is denoted by nu. Frequency is denoted by nu. NEU, nu. Our frequency is equal to distance traveled in particular time. Distance traveled in given time by wavelengths transmitted. For example, I will take the given point. And in this given point, how many waves are transferred? Maybe I will take the 10 seconds time. In these 10 seconds time, how many waves? Waves are nothing but one crest and one drop. Okay. Here, one more definition we will take it. Cycle. Cycle means completion of one crest and one trough. Okay. How many cycles are transferred in a given time and given point? Or the distance traveled in a given time. How much distance? Maybe it is a 1 meter distance. I will take it. In the 1 meter distance in a given time, how many waves are transferred? Wave is nothing but how many wavelengths? One crust and one trough. Okay. Then it is called as a wavelength, frequency. It is called as a frequency. The distance traveled in the given time, then it is called as a velocity. Nu is equal to the velocity denoted by the c and wavelength denoted by the lambda. Wavelength denoted by the lambda. Nu is equal to c by lambda. Then what are the units of frequency? Second inverse, or cycle per second, hertz. How to get the second inverse? Nu is equal to reciprocal of time period, 1 by t. Time period units a second. Okay. So these are the units of the frequency. Second inverse, cycle per second, hertz. These are the different units. And the remaining concept tomorrow I will discuss. Please subscribe the video and share the video. Wait and see, package smooth, set a boat,